All right. All right, so we'll make some decision trees in Colab here. I think I can make this narrower. All right, we're going to get the data set of those flowers, the famous machine learning training set. All right, that's going to import it from the pre-made data sets here, and then it's just going to print out some values to show it of the first. Okay, here's the instances. We've got the X and Y of the iris, which is petal length and petal width. And now we have 50 of each of the three categories here. So that's the data we're going to work with. And now we make a decision tree. And there's the decision tree. So the one you've seen before, it makes this if statement. If the length is less than 2.45, you go here, and that captures all of this category. Otherwise, you go here where you have a mixture of two categories. And so you have another decision that splits those in half, and now they're pretty well separated with a tree of depth 2 here. And I limited it with regularization here to maximum depth of 2. So we could go further, and but then we can try the predictions here. This is the one that shows how accurate the model is in a graphical form. So you see colors for categories, and you can see this category is perfectly separated, but these two categories do have some instances that are incorrectly. There's one blue in the where it shouldn't be, and there's 5 greens down where they shouldn't be. So we can change the depth. And if you change the depth, it will have 3 layers, and you'll get down here, and it'll, of course, do a better job. So that's one way to improve your model. And if we use the curve with noise here, this is one we've used before, x times cosine x plus some random noise to make just a curved thing to try to trace out. So there's x times cosine x plus noise, and we're going to fit that with a tree. And you see, here's it only takes a few layers down. This is because the maximum depth is limited to 2. So it's not going to do a very good job of fitting that curve. It's only going to have 4 possible answers, 4 possible values. So it's going to be like a very crude analog to digital transformation. And there you have it. There's only 4 possible values, 1, 2, 3, and 4. So it does a really rotten job of fitting through the data. But if you go to depth 6, then you'll get a much better fit, and you'll see a flag here. And in fact, down here, it looks like to me like you're getting some overfitting. This is jumping up and down in a way that I don't believe the real data does. So, and that's commonly the case. I mentioned it with large language models, even when they are trained by the professionals at Google and such, to where mostly they've just learned the tendencies of English. Authors find that if you put in a page of their book, it'll repeat other pages of the book verbatim. So that again suggests that it's overfitting, memorizing exactly the text that was put in instead of just learning the trend of the English. And that's going to have huge consequences. The lawsuit against all these large language models from the New York Times and others says your models are memorizing New York Times articles and then handing them out to people without paying royalties. And the defenders say, no, our models are simply learning the meaning of articles and writing things in a similar style the way a human did, and that might be described as fair use. So this is the argument. If they're overtraining, then they are just stealing content. Otherwise, they're just reading it the way a human would and learning from it, and maybe that's going to be accepted as fair use without payment. But we'll see. Anyway, and you can remove the limit entirely, and then it will spike every data point and be sort of crazy. So that's what I wanted to show you.